Assalamu alaikum. I'm Professor Dr. Haider Jawad Mubarak. This is a presentation to the topic of comparative anatomy of the respiratory system and part of the curriculum of medical biology for the second semester, first class, College of Medicine, An-Nahrain University. During development, the respiratory diverticulum developed during embryogenesis as a part of the subdividing foregut. There is a septum that appears in the foregut, which divides the foregut into two tubes, a dorsal tube, which is the oesophagus, and a ventral tube, which is called respiratory diverticulum, or is called the tracheal bud. Then after the tracheal bud elongates, and after elongation the tracheal bud divides into a bilateral bronchial buds. Each bronchial bud will then divide more and more to form the bronchopulmonary segments of the lung. This is a situation that is seen during embryonic development in higher vertebrates. But definitely the vertebrates shows adaptation for this form of organs that is serving for external respiration, and the adaptations depends on the environment where the organism or where the vertebrate is living, or the adaptation is depending on the functional need of that vertebrates. Definitely vertebrates which lives in air should have a respiratory organ that is different from that living in water, and vertebrates that is actively moving, just like birds flying in the sky, needs much modification in the respiratory organ than vertebrates that is not having such an activity. So the modifications in the respiratory organ is according to the following. Number one, some of the vertebrates will have ability of cutaneous respiration, which is respiration through the skin or via the skin. These vertebrates may shows exchange of gases via the skin, whether they are living in water or in air. And an example of these are the amphibian. Other vertebrates' respiratory organs may be represented in the form of gills respiration. And I think you know that gills are seen in fish. It is the organ of respiration in fish. And the gills simply are pouches that are appearing on the sides of the pharynx during embryogenesis. But these pouches in fish will modify after embryonic development to form the respiratory organ. Pouches are also seen in other vertebrates, the gill pouches, but they will not form respiratory organ in other vertebrates. Only the fish form respiratory organ from the gill pouches that are occurring during embryogenesis. Some of the gill pouches will have slits with outer opening that is not covered. The others may show slit or pouches that are covered by an opercula. Some of the vertebrates may have external gills as those of amphibia, which having the same principles. In addition to skin modification, the gills modification of the primary organ of respiration, another form of respiratory modification is the swim bag, or called swim bladder or gas bag. This is an organ that is usually found in fish, and although the fish breathe via their gills, arches or pouches, but the swimming bag or swimming bladder is an organ that is evolutionary similar or homologous to the lungs. It is derived in a manner during embryogenesis, or formed in a manner during embryogenesis that simulates the manner of lung formation by division of the foregut. And so, as this figure shows, we may have a swim bladder or swim bag or gas bag that is connected with the pharynx, or it may be connected with the esophagus. And this swimming bag may have a pneumatic duct that is connected with the esophagus. The function of the swimming bag or bladder is usually it acts as a hydrostatic organ, as the amount or the quantity of air in this swim bladder regulates the specific gravity of the fish, and so when there is much air, the fish will be in a higher level in water, and if the air in the swim bladder decreases, the fish will go down inside the water. And the gas in the swim bladder could come from the atmosphere if the fish have an access to the atmosphere, or what is usual is that the gas in the swim bladder is derived from the blood in an organ adjacent to the swim bladder, which is called red gland or red body. The red body contains blood vessels from which gas will diffuse into the air bag or the swim bag. And even the gas in the swim bag or swim bladder may be reabsorbed back to the blood via the so-called oval body. So the red body or gas gland produce the gas, and the oval body reabsorb the gas, and thus the gas will decrease and increase according to the level needed by the fish to float in a higher level in water or less level. However, this is the main function of the swim bladder, but the swim bladder is considered here as a modification of the respiratory organ because it could have other functions, which are hearing, sound production, and respiration. So it is discussed here with the modifications of the respiratory organs in vertebrates. When the swim bladder is serving for hearing, as in carp fish, it contains a bone that is connected with the hearing sensors of the inner ear or the labyrinth. And when it serves for sound, the swim bladder contains muscles in its wall that pushes the air in sub-chambers and thus producing sound. And when it is the swim bladder is responsible for a respiratory function, usually it is found to be subdivided by septa from inside to increase the surface area, which allows gas exchange between the air and the swim bladder and the blood. So, kind of modification in the primary respiratory organ responsible for external respiration, could be modification via skin respiration, cutaneous respiration, or via gills respiration, gill pouches, or via the swim bladder. The last modification, which is found in mammal, including human, is the lung, and there are some structures that are associated with the lung. The first part of the organs that is associated with the lung is the larynx, and I think everybody knows that the larynx in a human and in mammals is made of cartilaginous skeleton that are connected, or that is connected by muscles and ligament. It is not only seen in mammal, it may be seen in some amphibia and lizards, and the larynx shows or contains the vocal cords that stretches across the chamber and thus producing sounds in these vertebrates. The other organ that is related to the lung is the trachea and Sarnax. The trachea is a cartilaginous tube, extends below the larynx, and usually its length is as long as the length of the neck in vertebrates. The distal end of the trachea bifurcate into two primary bronchi. In birds, the bifurcation or splitting of the distal end of the trachea shows the Sarnax, which is the vocal organ in bird. So the splitting usually produce primary bronchi, but only in bird the site of splitting at the distal end of the trachea show the Sarnax, which is the organ of voice production in birds. It's only seen in birds. The lung itself, as a primary organ for respiration, also shows various forms of modifications. The lung may appear just like a sac on the right and left side, a bilateral sac. This sac could be a simple sac or septated sac. Such forms could be seen in turtles, in snakes, in lizards, and amphibia. Other form of sac that serves to provide thermoregulation in addition of providing much oxygen exchange is a form of lung on the right and left side, which is connected, or which are connected to diverticuli of air sacs. And these diverticuli are found extensively distributed throughout the body of the vertebrates. And usually this form, the diverticulated lung, is seen in birds, as it will provide much ability of gas exchange and also thermoregulation. You will see that the lung is small in size, but is connected to multiple diverticuli or sacs that are extensively distributed in the body of the bird. The final form of modification in the lung is the lung which is seen in human and in mammals, where you have lobulated, many lobes of lung. Each lung shows multi-chambers, and this form is the usual form that is seen in lung. The lung in a human is that seen in a human. The human lung is divided into many lobes. The right lung contains 3 lobes. The left lung contains 2 lobes, and each lobe is divided into many chambers or bronchopulmonary segments, and this form also seen in other mammals. Thank you very much.